Hello explorers and welcome to another video. Today we are going to look into more Advent of Code. We are going to play around with another puzzle. It's day 5 of Advent of Code. So let's jump over to this here, and this is the description. Binary boarding. You're board a plane only to discover the new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all over the flight attendees are busy with the flood of people that suddenly made it through passport control. You write a quick program to use your phone camera to scan all the nearby boarding passes, and that's our puzzle input. Perhaps you can find a seat through process of elimination. Instead of zone or groups, this airline uses a binary space partitioning to seat people. A seat might be specified like FBF, BB, FF, R, LR, where F means in the front and B means in the back, left means to the left, LL means to the left, and R means to the right. The first 7 characters is either F or B, and these specify exactly one of the 128 rows on the plane, numbered 0 to 127. Each letter tells you which half of the region a given seat is in. Start with the whole list of rows, and the first letter indicates whether the seat is in the front or in the back. The next letter indicates the half region the seat is in until you get left with one row, and then they have an example here, and it's pretty much binary search down in the different regions, upper lower, and then you do the same for right and left. And right and left is either right is the upper half or left is the lower path. So that's the thing that we need, and then we can have a seat ID where you take the current row and multiply that by 8 and then plus the seating value or column, and then you get an ID. So the first thing we need to figure out is which is the highest ID of seating in the plane at the moment. And we need to look at the puzzle input, of course. So we have a new puzzle input here. We have a new puzzle to solve. So puzzle 5A. And let's see here if we can create something here. And I think we can continue with this seating class. Seating. So that's what we need, and this will take an string and figure out which row and column it's actually in. And then we can figure out, we can get the ID for this seating. So that's the row times 8 plus the column. So that's easy enough. And then we have this string here, and I think we just need to loop through the characters, or we need to check the characters. And I think that the row is actually going to be, if we start at 0, then the row will be the S value, and we get char at 0, and if that's equal to back, then we will add 64, else we will add 0. So that's the first So let's see. Next up, we have this 1, and that will add 32, 16, 8, 4, 2, and 1. So those are the first 7 characters that we have. Then we have the 8th character, which is either a right or a left. And I believe that the right value was the upper half, yeah? So 8, and then we have 3 values of these, so 8, 9, 10. And if it's a right, then we will add a 1, a 2, or a 4. So that's pretty much what we need here. We change this column up to row, like that. And now we have the seating clause done, pretty much. This could have been done with using binaries and just adding to one number and setting specific bits and so on. But I think that's a harder thing to do than just adding the values. So if we have a seating here, seating, new seating. So that seating, take the first one here. If we take seating, get ID as out, we get that. Let's run that and see that we get the right ID for the first one. And we got string out of bounds, range 10. Okay. So what did I do wrong here? 6, 7, 8, 9. So that's more like it. Then we get 567, which was the first one. We take the next one. And that gives us what? 119, which is correct as well. We take the last one, test that as well. 820. So I think that we have something that works pretty well. So what do we do now? We copy. We just take everything that we had in our earlier puzzle here. Don't be scared about copy and paste. We have a lot of parsing to do. So here we only want to check this line like this. And in this case, we want to check this line. We want to have an max ID, which is the or largest ID. So that's the largest ID that we have found. So we will do this line and then we will check if the largest ID is smaller than the seating get ID. Then we will get the seating ID again and put that to the largest ID. So that's pretty much it. We don't need a passport list. And we output the largest ID at the end here. And this is puzzle input 5. So let's run that and see what is the largest we get. 878. Okay. So let's put that in and see if that is the correct answer. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. Yes. So let's continue to part 2. Ding! Fasten the seatbelt. Signs have been turned on. Time to find your seat. This is a completely full flight, so your seat should be the only missing boarding pass in your list. However, there is a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft. They'll be missing from your list as well. Your seat wasn't at the very front or back though. The seats with IDs +1 and -1 from yours will be in the list. What is the ID of your seat? Okay, so we need to find a seat within this list that have one seat that is free, and then have one seat above it and one seat below it. So that's interesting. That's an interesting challenge. It's a fully booked flight. There should be seats up front and back of me, but some seats are not filled because they are, So perhaps we could do like this. We can create an int array, let's say seats. So this is just very quick and dirty. Let's see if this works. New int array, and we give this an array of 2000. It's probably too much. I don't think that you can assign that much to a seat. So if you have, and we can actually look that up. What is the largest we can have? 227. So that's the largest row times 8 plus, and the largest seat was it 16? Seating, yeah, that would have been 8. So this is the largest value that we can have here. So that's 1024. So that's not that much, actually. So the seat wasn't very front. The seats with the IDs +1 and -1 will be in your list. So if we have a seats of 2000, we should have all the seats in one list. So here we can actually take all the seats that we get. We get the seating, get ID, and we add 1 to that. And if we stop the execution down here with the debugger, we should see in this list of seatings, you see here a lot of ones. You can go through the list here and see that we have a lot of ones that all fill out this plane. So we can actually manually find this seating that is missing. It's not the most impressive way of doing it, but that's the way. Okay, so here was the top of the list. It's 878 was the top. And that we actually knew that that was the largest one. So we should have a number that is 0 somewhere in this list here. So 54 is the first one. So let's do that then. 4 int I 54 I smaller than 878. I++. And then we will take the seats I, if that is equal to 0, then we will print the I. So let's see what we get then. So 504 should be our seat then. So we found the lower bound, we found the upper bound, and we only got one ID between those that was not filled. We could have printed all the ones until we got a 1 to see how much of the seats on the lower bound that was not filled. But I did this manually. I think that's just fine. Let's jump over and see if this is the right flight seat ID. Let's submit that. It was. You get a gold star. I get a gold star. Everybody gets a gold star. So we solved that one. Yes. I hope that you learned something today. I hope that you found this video interesting. If you have another solution, then please leave a comment in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.